In this section, we're going to talk about transport layer. OSI Layer 4 transport layer provides host-to-host communication services such as connection-oriented data stream support, reliability, flow control, and multiplexing for applications. TCP and UDP are the most common protocols used in this layer. Let's take a look to the TCP versus UDP. TCP is suited for applications that require high reliability and transmission time is relatively less critical. UDP is suitable for applications that need fast, efficient transmission such as games. UDP's stateless nature is also useful for servers that answer small queries from huge numbers of clients. Another difference is TCP rearranges data packets in order specified. UDP has no inherent order as all packets are independent of each other. If ordering is required, it has to be managed by the application layer. The speed for TCP is slower than UDP. UDP is faster because error recovery is not attempted. It's a best effort protocol. TCP does flow control. TCP requires 3 packets to set up a socket connection before any user data can be sent. TCP handles reliability and congestion control. UDP does not have an option for flow control, guys. And lastly, TCP is connection oriented. Once a connection is established, data can be sent bidirectional, but UDP is simpler and connectionless protocol. So, in computer networking, port numbers are part of addressing information used to identify the senders and receivers of messages. Port numbers allow different applications on the same computer to share network resources simultaneously. Let's say that we have a client in here, and let's say that this client wants to use different applications such as electronic mail, HTML page, like surfing on the web, and by using the internet chat maybe. If this guy wants to use this different application, it should use different port numbers to reach to these different applications. So, we have a command that we can use on our laptops, our PCs, or Windows machines or something like that. On the command line, if we type netstat, we can see some statistics. Netstat is a command line network utility tool that displays network connections for the transmission control protocol, both incoming and outgoing, routing tables, and a number of networking devices. As you can see in here, here are the source IP addresses. These are the source ports, and these are the destination ports that the user wants to reach. For example, in here, this guy wants to reach the 80 port and the communication is established. So, the port numbers in range from 0 to 1023 are the well-known ports or the system ports. They are used by system processes that provide widely used types of network services. For example, a well-known port is FTP, and FTP uses TCP protocol, and the port remote number of FTP is 20. For example, Telnet, this is a remote access protocol, and Telnet uses TCP protocol and protocol number is 23. And DNS, domain name system protocol, that can use UDP or TCP, and the port number is 53. In data communications networks, packet segmentation is the process of dividing data packet into smaller units for transmission over the network. Packet segmentation happens at layer 4 of the OSI module or the transport layer. Segmentation may be required when the data packet is larger than the maximum transmission unit supported by the network, and when the network is unreliable and it is desirable to divide the information into smaller segments to maximize the probability that each one of them can be delivered correctly to the destination. So, let's talk about the TCP and UDP details now. The client-server module is a distributed application structure that partitions tasks or workloads between providers of a resource or service called servers and service requesters called clients. For example, if you try to open the networkel.com webpage, your computer's web browser is the client that requested services from the networkel.com server, which technically is called an HTTP server, so you could read the web page of networkel. So in here you have as you see, we have some protocols that are using TCP protocol, and they are FTP, file transfer protocol, telnet, and HTTP. This is the protocol when we use when we are surfing on the web, as you know. So these clients are using some port numbers in this range, as you can see, and they're interacting with the server to get the services from them. For example, this PC1 wants to take an FTP service from the server, so it's using the destination port of 20 of the server. For example, this PC2 wants to take an HTTP service from the server, so it's using the destination port 80 while it's connecting the server. So let's go ahead with the three-way handshake. A three-way handshake is a method used in a TCP IP network to create a connection between a local host and server. It's a three-step method that requires both the client and server to exchange SYN and ACK, acknowledgement packets, before actual data communication begins. To establish a TCP session, we have SYN, SYN-ACK, and ACK steps. In the SYN step, client sends the session request to the server. In the response, the server replies with a SYN-ACK. Then finally, the client sends an ACK back to the server. For example, let's say that the client wants to establish a TCP session between the server. What client is doing first is it's sending a SYN packet with a sequence number of 1000. The server gets the SYN packet and replies back with a SYN and acknowledgement message and saying that my sequence number of this message is 2000 and I'm acknowledging that you send me the sequence number 1000 packet. Alright, and increasing the number of the sequence by 1, as you can see. Then the third step is the client is responding back with an ACK again and saying that this ACK has a sequence number of 1001 because my SYN's sequence number was 1000, and this is my next packet that I'm sending to you, and this has a sequence number of 1001, and I am acknowledging the packet that you send me with a sequence number of 2000, and the acknowledgement number session is 2001. Alright. When we try to terminate the TCP session, the steps we are using is the first fin, then ACK plus fin after this. The first is fin, then ACK, then fin from the receiver side, then this guy is sending an ACK again. The steps are fin, ACK, and fin, ACK. This is by B, these are by A. Let's talk about the TCP reorder process right now. If you want to send a packet from site A, as you can see in here, to site B, you have two different networks, and they are IP network 1 and IP network 2. When packets are being sent, segments may split to different paths. Some of them may prefer IP network 1, and some of them might prefer the IP network 2. TCP reorders these packets at the destination, and this process is known as TCP reorder process. This process is not available for UDP, guys. Please pay attention to that. The TCP windowing is an option to increase the receive window size allowed in transmission control protocol above its maximum value. The TCP window size is simply an advertisement of how much data the receiving device is willing to receive at any point in time. The receiving device can use this value to control the flow of data or as a flow control mechanism. As you can see in here, there's a TCP session between the PC and server. PC is sending a packet to this guy, and this guy acknowledged the first guy. Alright, then PC is sending the packet 2 and packet 3, and server is responding back with acknowledgement message again. But in here, this guy is sending 4, 5, and 6 to server, but this time what is going on in here is the acknowledgement number is 7, which means I couldn't get the sequence number 7, because in here, please pay attention that I am sending the sequence number 1 and the acknowledgement is 2. In here, I'm getting the sequence number 3 and acknowledgement is 4, but what means in here is I'm sending an acknowledgement of 7, which means I got the sequence number 6 lastly. Then the PC is sending the 7, 8, 9 again the 7 and plus 8 and 9, then the server is acknowledging with the 10, and that means everything is okay. So let's take a look to the UDP protocol some now. UDP provides, as I told you, unreliable data transfer, and as I told you again, we don't have a reorder process. That's a connectionless protocol, and loss of my data may occur, and used for application that requires fast delivery and no delay. And UDP has a client-server module as well as TCP/2. The protocols such as DNS, TFTP, or SNMP are using the UDP protocol. So for example, if PC1 wants to get the DNS server from this guy, that sends the UDP packets and saying that, hey guy, my destination port is 53, that means I need that DNS service from you. For example, let's take a look to this client, which is PC2. This is an SNMP client, and SNMP uses UDP also, so this is sending UDP message and with a destination port of 161 to get the SNMP service from this server.